Hi, in the last section, in section 9.8, we discussed about power series, right? If you remember that, we mentioned about the power series centered at C is given by summation n equals to 0 to infinity a sub n and then x minus c to the n, okay? Which if you expand, you plug in n equals to 0, you will get a0 times x minus c to the 0, which will be 1, so that will be just a0, right? And then plug in n equals to 1 will give you a sub 1 x minus c to the 1, right? Similarly, if you plug in n equals to 2, you'll get a sub 2 x minus c to the 2, and then so on, and continue that way, okay? That's what we discussed. So this is the power series centered at C, right? So if C is 0, then how would that look like? If C is 0, then your power series will look like summation n equals to 0 to infinity, right? So n equals to 0 to infinity, and then you will get a sub n, right? A sub n, and then x to the n. You see that? So if C is 0, then how would that look like? That would look like a sub 0, right? And then plus, and then x minus c. Instead of c, you will plug in 0, so you will get a sub 1 x, right? And then plus, if you plug in n equals to 2, you will get a sub 2, and then x a sub 2 x to the square, right? And then plus, and then so many other terms. You see that? So that's what you get. So also how the geometric series, if you remember from the beginning of this chapter 9, geometric series, if the absolute value of x is less than 1, meaning if the common ratio, absolute value of the common ratio is less than 1, or if the common ratio lies between negative 1 to positive 1, that's what the absolute value of x less than 1, right? If the common ratio is between negative 1 and positive 1, then n equals to 0 to infinity a times x to the n. This is a geometric series, okay? How we know that it is a geometric series? Because if you take the ratio between the two terms, between any two successive terms, right, you will get the same number. That is the common ratio, that is x, okay? Because you see that if you expand this, then you will get a plus ax. When you plug in n equals to 0, you will get ax to the 0, that is just a, plus ax when you plug in n equals to 1, plus when you plug in n equals to ax squared, ax cubed, like that. Now, is this a geometric series? Yes, because if you take the ratio of ax divided by a, it is x. Ax squared divided by ax, that is x. So meaning that if you take the ratio of any two successive terms, you will get the same number all the time. So that is the geometric series. Now, we learned that if the common ratio x is less than 1, then this geometric series has the finite sum, which is given by a over a is the first term, right? A over 1 minus x. That's what we learned, okay? That is the infinite sum of the geometric series, a over 1 minus x, okay? Now, so thus you can write a over 1 minus x equals to n equals to 0 to infinity a x to the n when absolute value of x is less than 1. This is how you can write, right? Because for this function, okay, for this function you can write a series, you can write an infinite series. But if you write this infinite series as that format, right, then you get summation n equals to 0 to infinity a x minus 0 to the n, which means this is a power series with center at 0. That's what we can say here. You see that? So which is a power series centered at 0. Now, let us find out a power series of a function, okay, fx equals to, let's say, 1 over 4 minus x, center at c equals to 0. Also find the interval of convergence. Okay, this is a problem from the book. So the question was asking, find the power series for the function f of x was 1 over 4 minus x, centered about x equals to 0. Center at x equals to 0. Okay, center at x equals to 0. Also find the radius, the interval of convergence. Interval of convergence. Okay, so this is that question, right? Because it was hard to write on that app, so I'm using the different app for here. All right, so what it says is, and that example is, find the power series for fx equals to 1 over 4 minus x centered at x equals to 0. Okay, also find the interval of convergence. So here the idea is, again, you try to, because we are given as solution, we are given as the function is 1 over 4 minus x, right? But you want to change that into in the form of 1 over 1 minus gx, that format, right? So you want to convert that function into that format, right? Into that format. So how do I do that? Is, let me write this as 1 over, let me take out 4. How do I write that? You can write 1 minus x over 4. Because if you distribute that, you will get 4 minus x, right? Now, this can be written as 1/4 on the top, and then 1 minus x over 4 at the bottom. You see that? This is what you get. Okay? Now, this can be written as, it is like a over 1 minus r, or 1 minus gx, right? So a over 1 minus gx. Basically, you want to change that as a over 1 minus gx. A is 1/4. And then 1 minus x over 4, 1 over gx, like that, right? But what is the formula for that? This is basically, that can be written as, this guy can be written as summation n equals to 0 to infinity a, and then what? Gx to the n. That's what you can write, right? Because a over 1 minus r can be written as a r to the n, or ax to the n, like that. So this is the common ratio, gx is the common ratio here. So you can write this as summation, okay, n equals to 0 to infinity, right? And then a is 1/4, and then gx is x over 4 to the n. This is the power series representation, right? At x equals to, at c equals to 0. That's what you get, okay? This is the power series format, power series representation of the function 1 over 4 minus x, okay, at x equals to, at c equals to 0. So if you want to simplify, you can keep like this, or if you want to simplify, you can write this as 1 over x to the n over 4 to the n plus 1, like that, right? So that is not a problem. Or just write like this, okay, because that 4 and 4 matches. You can write, if you want to, you can write like this as summation n equals to 0 to infinity, right? And then x to the n over 4 to the n plus 1. Not a problem. You can write like that, the final answer, because that 4 and 4 matches. Now, the another question is, find the interval of convergence. So when does this geometric series converge? The series converges if that common ratio is less than 1, right? X over 4 is less than 1. You see that? What does that mean? That means you can write that as, if -1 is less than x over 4 is less than +1. If you multiply by 4, you will get -4 is less than x is less than 4. That is, the interval of convergence is -4 through 4. That's what you get, okay? That is the interval of convergence, okay, guys? So let us do a few more examples, okay, and then you will have some idea. Because in this example, what we did is basically we took this series, this function, that is the given function, and then we found the equivalent series representation for that function, okay? So let us see a couple more examples. I want to take another example as example number 5 from the book, okay? So that is example. So the question is same, find the power series representation for here the function is fx equals to 4 over 3 plus x, and then we want to find centered at x equals to 0, c equals to 0, because c is the notation for center. And also you want to find out the also find the interval, of convergence. Okay guys, all right, let us do the same technique. So we have 4 over 3 plus x, okay, 4 over 3 plus x here. Now our goal is what? You want to write in the form of a over 1 minus g of x, in that form, okay, because you want to write as x minus 0 kind of format, right, because your center is 0, okay, so that g of x will have like x over something, that could be x over something, or x minus whatever over something like that. So you will see that, okay. So basically you want to write a over 1 minus gx format, okay guys. So let us try that. So this can be written as, there is 4, let me take 3 out here. What do you get? You get 1 plus x over 3. So this can be written as 4/3, okay, and then 1 plus x over 3. But our formula needs 1 minus. So how can you write that? It is like 4 over 3, that is a, and then 1 minus, you can write negative x third, not a problem. That is same as 1 plus x third, right? Now this is in that format, you see that? So how can you write that in the series format then? So because if it was that case, then you could write summation a and then gx to the n. That's what you can write, right? So similarly here you can write that as n equals to 0 to infinity. A is 4/3, right? You see that? 4 over 3, and then gx is negative x over 3 to the n. You see that? That's what you get. And this is the geometric series, right? And again, as in the last example, you can simplify this and write like this: n equals to 0 to infinity, and then you can write basically 4 and then negative 1 to the n, and then also x to the n over 3 to the n plus 1. If you want to write this format, that is perfectly fine, because I just simplify that, right? But here I want to find out the interval of convergence. How do I find the interval of convergence then? So let us try that. So to find out the interval of convergence, this is a geometric series with common ratio negative x over 3. So the interval of convergence, convergence, because this series converges if the common ratio is less than 1. It is how do you do that? Negative x over 3 is less than 1, right? That is basically what? That is same as, because there is absolute value, okay, so you can write negative x over 3 or positive x over 3. It is same thing, right? So you can write negative 3 is, you can write, let's write down that x over 3 is less than 1, right? And then so you can write this as negative 3 is, and then you can write this, so you can write negative 1. Let us write down that way first. Oops, is less than 1. So this can be written as negative 1 is less than x over 3 is less than positive 1, right? So if you multiply by 3, negative 3 is less than x is less than 3. So the interval of convergence is negative 3 to positive 3 for this function, okay, or for this series, okay guys. So that's how we got, this is how we represent a function by a power series center at 0. So in the next example we will see some of the functions that we will represent them by a power series center at any other values of c different from 0. Okay guys, all right, thank you.